Hello everyone, in this session we'll discuss a question on random variable. So let's see this question, or we can say example, to understand every terms for the random variable. Tossing two fair coins with x denoting the number of heads appearing. Basically we have to find all the terms related to random variable, right? So for two coins, like with outputs 1 by 2 and 1 head and tail, the possible set of outcomes can be tail and tail, tail and head, head and tail, and head and head. We have four sets out of two coins. Like out of one coin we can have two sets, head, tail. For two coins we can have four sets. For three coins we can have 8 sets, and like that. So since the coins are fair, all these cases 1, 2, 3 and 4 will have the same probability as 1 by 4. Why 1 by 4? Because we have number of cases to be 4. If we had it like 3 coins and with 8 cases, the probability would have been 1 by 8. Right? Now x is the random variable. Obviously it will be a discrete random variable, which is number of heads. So you can see what is the number of head here? 0. Number of head 1, number of head 1, and number of head 2. So for x equal to 0, x equal to 1, and x equal to 2. So let's describe it. What is the probability density of these values? This is the case of x equal to 0, and these two together will make x equal to 1, and this makes it equal to 2, right? So out of 4 cases, for x equal to 0 we have one case, so the density of x equal to 0 is 1 by 4. For x equal to 1, the probability density will become this case plus this case. So density of this is, probability of this is 1 by 4, probability of this is also 1 by 4. So 1 by 4 plus 1 by 4 becomes 1 by 2. And probability that x will take 2 is this case, single case. This is 1, 2, 3 and 4th case. So the probability for this individual case is 1 by 4. So these are the density. Now what does it mean? This means that x can take only these three values, 0, 1 and 2. It cannot take x equal to 3, it cannot take x equal to minus 1, because the number of heads are going to be positive or 0, non-negative. And maximum it can take value 2. The density is going to be 1 by 4, so there are 25% chances that x will be 0, 50% chance that x will be 1, and 25% chance that x will be equal to 2. So this is the density function. Since this is density function. Next is f of x, that is distribution function or cumulative distribution function. And we saw that cumulative distribution function is all the densities up to that value. It is sum of all the density. For the case of discrete, it is sum of all the densities up to that value. So for this case we don't have any value less than 0. So we'll add only the density of x equal to 0 here, right? We don't have any value less than 0. We have only x equal to 0. So density, the only density is 1 by 4. So the sum will be 1 by 4. Next will be x equal to 1. Cumulative distribution function for x equal to 1. This means we'll have to add all the densities up to x equal to 1. This was up to x equal to 0. This is up to x equal to 1. So up to x equal to 1 we have 1 by 4 and we have 1 by 2. So this is 0.25, this is 0.5. Together it will make 1 by 2 plus 1 by 4 equal to 3 by 4. Next is probability distribution function for x is equal to 2. So for x equal to 2 means sum of the densities up to x is equal to 2. So 1 by 4 plus 1 by 2 plus 1 by 4 will give 1. And like we have studied, the sum of all the densities will give you 1. So there are only 3 densities possible, these 3, and sum of these 3 is giving you 1, right? Now let's try to see this in the graphical manner. Let's say this is x and this is p of x. So this x can take only 3 values. It is 0, 1 and 2. This is 0, 1 and 2, right? For x equal to 0, the density is 0.4. Let's say this is 0.25. 1 by 4. So this is the density here. Density at x equal to 0 is 1 by 4. Let's say this is 0.5, that is 1 by 2. So at x equal to 1, the density function is 1 by 2. And at x equal to 2, the density function is again 1 by 4. So this is the density function, and then we can see what will be the distribution function. Let's say this is f of x. Let's say this is 0.25, 0.5, 0.75 and 1. Fine. 1 by 4. One by 4, 1 by 2, 3 by 4 and 1. Fine. So in this case, this is x equal to 0, this is x equal to 1, this is x equal to 2. So for distribution for any value less than 0, it will be 0 because we don't have any densities less than 0. So up to x equal to 0, the distribution function is going to be 0. We don't have any densities below 0. And abruptly at x equal to 0, this will come out at 1 by 4. And up to, like right before 1, this will be 1 by 4 up to this. I'm making a dot here so that you can see it will be continuing from here. So from this value, 1 by 2 and 1 by 4 will add, and this will continue from here. So up to x equal to 2. Right before x equal to 2 it will stop, and from here, so this was 1 by 4, then 1 by 4 plus 1 by 2 became 3 by 4, and 3 by 4 plus 1 by 2 becomes 1. So from 2 onwards this will remain 1. So you can see, either if you want you can connect this also. So it is a step function. We can see it is a step function, obviously increasing function or non-decreasing function, you can say. It is non-decreasing function, right? So this is the distribution function, this is the density function. Now there are more terms we can find, like we have found density function, we have found distribution function. What if we need to find the probability for an interval? Like we have to find probability for x greater than 0 and less than equal to 2. So less than equal to 2. So that means it will be f of 2 minus f of 0. Why? Because 0 is not included. Fine. If it had been less than equal greater than equal to 0 and less than equal to 2, then we would not have considered f of 0. It would have been f of less than 0. Fine. So for now f of 2 is 1 and f of 0 is 1 by 4. So this value is nothing but 3 by 4. Fine. So this is it. Probability for an interval is this value.